Okay, today in class we talked about some of the interesting angles that show up when we look at parallel lines. And we gave them lots of names. Today we're going to recap those names and we're going to take a look at what conclusions we can make based on information given to us. So up here we have some intersecting lines. And our given information right now is that P is parallel to Q. One way we can actually mark that is by drawing arrows on line P and line Q, like so. Those are parallel. We also know that M is parallel to N, so we will draw parallel lines on this. But I want these to be different than the original ones to show that only these two are parallel and not also parallel to P and Q. So we'll put double arrows on these. Those indicate parallel lines. We're also given that the measure of angle 3 is 102 degrees. I'm going to write that number in here, 102 degrees. That information will come in handy for answering our question. So the question we're going to answer right now is to find the measure of the angles that I have listed. But I'm also going to justify those using the properties we talked about today. Those should pop up on the screen for you with the names. So we'll look at measure of angle 5. Here's where measure angle 5 is. Here's where measure angle 3 is. These angles are called alternate interior angles. They are on alternate sides of the transversal, but they are inside of the parallel lines M and N. Thus alternate interior. So 3 and 5 are going to be congruent in angle measure. If we have parallel lines, alternate interior angles are congruent. So this will read 102 degrees. For the measure of angle 6, this angle, we can use the same 102 degrees, but identify how 6 and 3 are related. 6 and 3 are both inside of the parallel lines, but on the same side of the transversal. We call those interior angles on the same side of the transversal. And we also know that interior angles on the same side of the transversal are supplementary. So those must add up to 180 degrees. So this angle and 102 degrees have to sum to 180. In reverse, 180 subtract 102 will give us 78 degrees. So the measure of angle 6 is 78 degrees. Now, since we're using the same diagram, I'm going to fill in this 78 degrees. It may come in handy for us later in the problem. Now we're going to look at measure of angle 11. Angle 11, as it relates to angle 3, they are both in the same position. They're in the bottom right-hand corner of both of these intersecting lines. Angles that share the same position are called corresponding angles. So angle 3 and angle 11 are corresponding. And we know by our parallel lines postulate that when parallel lines are congruent, corresponding angles are congruent. Therefore, angle 3 and angle 11 should have the same angle measure of 102 degrees. Okay, I'm going to indicate that on our diagram as well. Now we're looking at measure angle 7. Here's angle 7. Angle 7 relates to angle 3 also by being corresponding angles. They're in the bottom right hand and the bottom right hand of either of these intersecting lines. So by the same reasoning we used to say that 11 was 102 degrees, so is angle 7. Also note that angle 7 and angle 6, these two form a linear pair, which means both angles form a line and also means that they sum to 180 degrees. So I could have used the information from angle 6 being 78 degrees along with angle 7 summing to 180. So this is 102 degrees also because of these being linear pairs. Let's take a look now at measure of angle 15. Here's 15. It's hard to relate 15 to angle 3 without going through a different step. And so I labeled earlier that 11, angle 11, was equal to 102 degrees. I can relate angle 15 to angle 11 by one of our definitions. These two are corresponding angles. We have two parallel lines cut by a transversal. These are in the same locations, bottom right-hand corner. So 11 and 15 are corresponding angles. So they too should be 102 degrees. I also want you to note that angle 15 and angle 5, which we learned earlier was 102 degrees, those two are exterior to these parallel lines and on alternate sides of this transversal N, which makes 5 and 15 alternate exterior angles as well. And by our proofs today in class, if we have parallel lines, then alternate exterior angles are congruent. So I also know that 5 and 15 are the same, justifying again the 102 degrees. Let's take one more look at the last angle here, 14. This is measured angle 14. It can relate back to 11. These are interior angles on the same side of the transversal. They're inside of the parallel lines on the same side of the transversal. So we know they should be supplementary. So this 102 plus the angle we don't know should add to 180. Therefore 14 should also be 78 degrees. Hopefully by now you've noticed that there are multiple ways to get to these answers. The trick is to relate them back to the definitions and the rules that we have for parallel lines. Alternate interior angles, if you have parallel lines, alternate interior angles are congruent. Alternate exterior angles are congruent. Interior angles on the same side of the transversal are supplementary. Exterior angles on the same side of the transversal are supplementary. Vertical angles are still congruent, and corresponding angles are congruent. If you can relate the angles back to those definitions, then you'll be able to say angle measures based on the given information.